We've got a simple write example up and running, where we know that we're creating one shopping list. And that shopping list is stored as JSON data in the Firebase database. But that's only half of the story. Let's see how we can get data from the Firebase database and display it in our app. In a standard database model, you might think of your data storage as a resource to get data from. If I wanted to display, say, the name of a shopping list, I'd probably start a different thread in the app that's requesting the shopping list. Something like an async task. And I'd use this separate thread to connect to the data storage and ask it for the data that I'm interested in. Then that thread would wait a bit and the server would respond. Finally, the app would then take the response that I got from the database and update the UI. Now, if I expect this value to change, I might regularly ping the data storage to see if the value has changed. And then I'd wait, and each time I'd wait a little bit and the server would respond back to me. And to make things a little bit simpler, I could do this with something like a sync adapter. Now, this model of making a request, waiting, and then receiving data and putting it into the UI is known as the request-response model. The issue with this model is that because you're constantly pinging the server, it can create a lot of unnecessary network traffic and be a bit annoying to manage. Firebase takes a much different approach. Instead of constantly refreshing data, you tell the server once, let me know if anything about this data changes. Then let's say something about the data does change. Once Firebase gets the change, it'll send it out to all of the apps that are connected to it. And then it's up to your app to take this data and update the UI. So the Firebase steps are, you set up a listener once, and then whenever the data changes, you receive the data and put it into the UI. So in Firebase, data ping you. So what does this look like in practice? Here, I have a drawing of a table in Firebase. This is the root node. It has children A and B. A has a children C, which has some value. B has a children D and E. E has some value, and D has one child, F, which has some value. Reading a Firebase database is all about listeners. Okay, so this is my best attempt to represent a listener. It is a drawing of an ear, and a listener will be attached to a specific node in your database, and it will also be connected back to the app itself. And that's this first step, where we attach a listener. When the data changes, this listener will trigger part of your Android code. It's a lot like how if you press a button, a on-click listener is called. It's just the button press is changing a piece of data somewhere. When your Android code is triggered, it's actually also passed an argument, which is the updated data that was in Firebase. You can then use this updated data to change the UI. In this way, you've got a connection to some sort of data in Firebase that will immediately update the UI whenever it changes. I should mention that the listener doesn't need to attach with a location with a single piece of data. It can actually be attached to a location with multiple children, like B here. The location can even have grandchildren, and so on. Then, if any part of this tree changes, the listener here will be triggered. So if this value here changed to 9, the listener here would trigger. And it wouldn't just send B back to the app, it would send B and all of its children, including D and F, even though F and D did not change. What's neat is that the Firebase SDK deals with all of the threading and all of the asynchronicity. So you'll notice that I didn't make an async task, I don't have sync adapters. Basically, the only things that I need to worry about are choosing which data to listen to, and then providing a method that can handle the data that comes back from the listener, which will usually change something that the user sees or experiences. Okay, so here I am in my app's dashboard. My data tree is right here. It is a root node and then one child, list name, with one piece of data. In this case, I want to know when list name changes. So, what URL location do you think that we should be listening to for changes? And when that location changes, what should we do with the data? Here's a box to enter the URL, and here you can describe in your own words what you want to do when the listener is triggered.